Today we're going to learn to solve quadratic equations by graphing. You can use the date of May 4th on your notes, and your note packet has 4 pages to it. We've been solving quadratic equations for a couple weeks now. We have a couple different methods that we can use to find the roots or the solution set to the quadratic. The easiest method is called the product sum method. So we're looking for factors of C. They also have to add up to the linear term B. This method only works when the value of A is 1. From there, we learn the grouping method. We use this method when the value of A is greater than 1. This will help us find the two roots. It's possible that they are fractional. And most recently, we learned the method of completing the square. This method works when A is 1 or greater than 1. But we have also another method that will help us solve the quadratic equation, and that's by graphing the function itself. When you graph a quadratic equation, the solution set or the roots that you obtain are really x-intercepts. These are the locations where your graph would cross the x-axis. We have 3 different options that are possible when we factor or when we graph. The first option is if I were to factor a quadratic and get 2 factors or 2 roots. That means when I graph the quadratic equation, I'm going to have 2 locations where the graph crosses the x-axis. So I have 2 real roots. When I factor a quadratic equation and I have 2 identical roots and we only list one as a solution set, that tells me that when I graph my quadratic, that graph will hit the x-axis 1 time, which means I only have 1 real root. And in some cases, you're going to find that your quadratic equation is not factorable. No matter what you do, you're just not able to break it down into its factors or roots. So we would say that there's no roots. When you graph it, this last image shows that the quadratic equation never crosses the x-axis and therefore has no real roots. The graph of a quadratic equation has a name of a parabola. You'll see in the picture, this is a smooth curve. It has a U shape to it. It's also possible that this parabola could be graphed upside down, so the U would be upside down, shaped more like an umbrella. So if we're going to graph our quadratic equation, the first step is to put the quadratic equation in standard form. We don't necessarily have to have A as a positive value, but it is nice to keep it that way. Now we're going to use our iPad to help us graph. So you're going to enter the quadratic equation into your calculator, and we're interested in a table of values. We could calculate this by hand, doing some simple math, but we'll let the iPad or the calculator help us. We want to make sure that when we create our table of values, we focus around the turning point. In this picture up here, the turning point is where the smooth curve stops and changes directions. So we want to make sure that that point is present in our table. We're going to plot the points. We want to use 5 to 7 points. One of those has to be the turning point, and then it's nice to have 2 to 3 points to the left of that turning point and 2 to 3 points to the right to get a nice U shape. When we graph a parabola, it is a smooth curve. We want to make sure that we put arrows on the highest points or the lowest points, and we want to write the equation on the graph as a label. The values that you see in the table representing the range, or y values, should show a repeating pattern. And that repeating pattern is what causes the parabola to form the U shape. So if you don't include the turning point, the points you graph might appear to look like a straight line, and that should be our first indication that something is wrong with our graph. Let's start with example 1. We're going to first factor this quadratic equation completely. Now, normally we don't have f of x, we will have 0. So I'm going to replace that. This method, I'm going to use product sum. I'm looking for numbers that multiply to 8, but also add up to -6. So that tells me that the factors are both negative, and I'm going to use -4 and -2. So I'm replacing f of x with 0, and I have two binomial factors. At this point, we'll set each factor equal to 0. So I have a solution or a root at 4 and another solution or root at 2. So at the end of factoring, I would list my solution set as 2 and 4. But now we want to graph this and see if we get the same result. I should have 2 points that cross the x-axis. On your iPad, if you'll go to Add Graph, and up at the top, the cursor should be flashing. You're going to enter in your quadratic equation. And when you hit enter, you should see the quadratic equation graphed. Now, this will be helpful before we make our own graph by hand, but you can see that the parabola crosses the x-axis at +2 and again at +4. Those are the roots that we obtained when we factored the quadratic. Your iPad also has the ability to display a table. So you're going to select the wrench, and then you're going to select table, and then split screen table. You might not be able to see the turning point, but you can use your finger to scroll up and down on this table on the right-hand side. It looks as though my parabola is turning at +3 on the x-axis. So right here, you can see that 3, -1 is a graphable point. But we talked about having a repeating pattern, so the value above it and below it are 0. And the values above and below that are both 3, and they're 8. So that repeating pattern is going to allow the graph to form a U shape. So now we're going to graph our own. I copied the table over. I want to make sure that I plot 3, -1. So here's 3, -1 right here. And then I'm going to plot 3 points above it. So 2, 0, 1, 3, and 0, 8. I'm also going to plot 3 points after 3, -1, so at 4, 0, 5, 3, and at 6, 8. You're going to go ahead and sketch a smooth curve. These don't always look really great at first, but I'll give my best here. Oh, that's terrible. We're going to put an arrow on this end, and we're going to swing up on this side and put an arrow. You're also going to label your quadratic somewhere on the graph. And we want to list the x-intercepts, which are the roots. So we could clearly see on this graph and the one generated by the iPad that the roots are at +2 and +4. So that's my solution set. So it's graphable, but we can also double check it by factoring it. All right, in example 2, they want us to factor completely this quadratic. You'll notice the value of a is -1. We really want to try to keep a +1. So what I'm going to do is remove a GCF of -1. F of x will become 0, and these terms that are left over, I'm going to factor those. And again, I'm going to use product sum. So I want it to multiply to 16 and add up to 8. So we'll have two binomial factors that are x plus 4, and we have our GCF, which is also a factor of -1. Our first factor gets set equal to 0, and this cannot be true, so this is one that we will reject. We have x plus 4 giving me a root at -4, and actually we have a second root at -4. But when we write our solution set, we know we're only going to list that factor once, so we have a solution set at -4. This tells me that when I go to graph my quadratic, it should only cross the x-axis in one spot. So we're going to graph this function ourselves. I did copy my table from my iPad. Negative 4, 0, this is my turning point. So I'm going to plot negative 4, 0. And I'm going to plot 3 points above it. So negative 5, negative 1, negative 6, negative 4, and negative 7, negative 9. We're going to go the other way now. So negative 3, negative 1, negative 2, negative 4, and negative 1, negative 9. So this parabola opens down like an umbrella. We're going to try to create a smooth curve here. Arrows. And an arrow. Don't forget your label, so put your quadratic function right on the graph. And we want to list the x-intercepts, which are our roots. We can see right here it only crosses at negative 4, 0. So the root is, oh, this should be negative 4. And our final example, number 3, they want us to factor completely. I'm going to go ahead and start by pulling out a greatest common factor, and I'm going to replace f of x with 0. So I'm going to remove 2 from each of the terms. Now I want to factor the quadratic term that is left over. So the goal would be to have factors of 2 that also add up to 2. But as you think about that, 2 and 1 are going to add up to 3. And even if it was negative 1 and negative 2, it would add up to negative 3. So at this point, the remaining trinomial is not factorable. So what does that mean for my graph? I'm going to go ahead and plug this into the iPad in its original form. And when you look at it, the reason it's not factorable is because it does not hit the x-axis. So there are no real roots or factors. So I copied the table from my iPad. It does have a turning point right here at negative 1, 2. So we can go ahead and plot as many of these points as possible. So there's my turning point at negative 1, 2. Oh, let me move that up. Right there. And then I'm going to plot negative 2, 4 and negative 3, 10. Now this time I was only able to get a couple points on the left side. We'll also plot 0, 4 and 1, 10. So there's only 5 points in this diagram. That's okay. We still get the U-shaped curve. And we'll put arrows on. We will label. Now when they ask you to list the x-intercepts or the roots, and I can clearly see that there are none, you have to say that there are none, or you have to say no solution. Otherwise, they'll think that you did forget about that part, when clearly there just wasn't an answer. This is homework number 109. It says solving quadratics by graphing. Make sure you go through and answer part 1 and part 2. There's a lot of white space on there for you to do your work. If you have any questions about this set of notes or your assignment, please make sure you contact me. Have a great day.